Good day, everyone. Today is the fourth lesson of the third chapter. We are focusing on functions. Whole ton of information coming your way. Of all the videos you watched so far, I would say today has the most information. So buckle up. Here we go. I would suggest watching this more than once with all of the information coming your way. We'll also have some clarification the next day we meet together in class. In our classroom notes too. So here we go. Whole bunch of definitions for you to know. A function is what we're working on today. A function is a rule that relates two quantities so that each input value put into the function or the equation represents one output value or the answer. A couple things to know. An input value. An input value would be what you put into an equation or the number you plug into the equation. A function is simply the equation. We'll talk about the function when we get to one here. And then the output is going to be your answer. Output's going to be your answer. An input. An input is be the x. When you have an ordered pair x, y, the input is going to be the x. So when we look back up here at the definition for function, the input value is going to be the x value. It's going to be the value you're plugging into an equation. So when you have an equation like y equals x plus 1, you are going to, when you have the value y equals x plus 1, the x is going to be your input value, and the y will be your output value, which is number 3. The y in an ordered pair, the value that is produced are the answer. So as you can see here, the y is going to be your answer, y equals, the x is going to be your input so that you can get that answer. Number 4, domain. Domain basically is the x. It is the set of all possible input values. If you'll remember back to our last lesson, we put in a whole bunch. I said you had to actually put in 3 different inputs or 3 different values for x in order to graph an equation. So you're going to have a domain, or all of the possible input values are all of the possible x values. Range then would be the y values, the set of all possible output values. When you plug in x, a lot of times, most of the time, not all the time, the y will change, so the y or the range would be your outputs. To put all of that into perspective, because it sounds like a lot of the definitions here mean the same thing, number 6 then says that the x is the input and the input is the domain. So the x value in an ordered pair is the exact same thing as the input, and the input is the exact same thing as the domain. All of these really mean the same thing. Ditto for number 7. The y is the output, and the output is the range. The y is the range, the output. The range is the output, it is the y. Basically all of those things, they really just mean the same exact thing. But it's words that you need to know and words that you're going to be looking at and working with. Let's go to number 8 here. Number 8, if I give you the equation y equals 3 minus x squared, you know what to do with this equation in order to graph it. I'm going to ask you to graph y equals 3 minus x squared. We talked about this in a previous lesson. You don't know what x, you don't know what y is, so we're just going to start easy and make it up. Start at the beginning, put in 0 for x. When you put in 0 for x, you get 3 minus 0, and your y is going to be 3. So we've got the point 0, 3, but let's keep going. Let's put in 1 for x, or an input. 1 for x would be 1 times 1, so 1 squared, and 3 minus 1 is 2, so your y is going to be a 2. And as I told you, you need to have at least 3 points plotted on a graph in order to graph it. So let's do the number 2. 2 times 2 is 4 when you plug it in for x, and 3 minus 4 is negative 1 for y. So let's see what happens when we graph that. We got 0, 3, so we go over 0 and up 3. 1, 2, over 1, up 2. And we've got 2, negative 1, over 2, down 1. Does not look like we're going to have a straight line here. It looks like we've got some sort of curve going on. Okay, not a straight line. In this situation, just because I'm curious, I'm okay with you just graphing 3 points, but just because I'm curious, I want to see what this truly looks like by plugging in a negative 1. So if I plug in a negative 1 for x, I go over here, I plug it into x squared. Negative 1 times negative 1 is 1, and 3 minus 1 is 2 for my y. So let's just graph that and see what happens. Got negative 1 and 2. It looks like our graph is going to form a little bit of a U shape. So, inputs, outputs. X could also be called the domain. Y could also be called the range. So we've got x, input, domain, y, output, range. Really, if you think about the meaning of those words, they should make sense. Since we're inputting a number for x, we are getting, that is our input, and since we are giving an answer or an output for y, because y is our answer when we're writing the slope-intercept equation, it makes sense that that's the output or the answer. Moving on, number 9. We got y equals x plus 1. The equation y equals x plus 1, we want to graph, again, our slope-intercept equation. We're going to plug in a 0 for x and get 1 for y, a 1 for x, get a 2 for y, a 2 for x, and get a 3 for y. Again, we're plugging our inputs, our x's into that side of the equation. Our graph, over 0 up 1, over 1 up 2, over 2 up 3. You see a pattern. Try to draw a straight line as best you can. And we got ourselves a nice graph that looks like it's just simply a straight line. We'll come back to this one in a second. Let's go to number 10. Number 10 is the vertical line test, another vocabulary word. Vertical line test is after you create a graph, place a vertical line on the graph. If the vertical line only intersects the graph at one point, then the graph is a function. So now we have a couple graphs that we've already created, and we have to determine if they're a function or not. If it intercepts the graph in more than one place, it isn't a function because it has more than one value or one output for its input. Again, I told you there's a lot of information, so this might be one you have to rewatch. Let's go back to number 8. Number 8. If I drew a vertical line, the vertical line test, if I drew a vertical line anywhere on my paper, I'm going to draw one there, I'm going to draw one here, doesn't matter. Any place I draw a vertical line going through this graph, it is only going to intersect my graph in one spot. It intersected it right there, intersected it right there, intersected it right there. I could draw a line right here. It only is intersecting it in one spot. Therefore, this is a function. So if the question is this graph a function? Your answer is yes, because of the vertical line test. Again, if you confuse what the vertical line test means, go back and reread the definition, or go back and re-listen to the definition. Let's look at number 9. Again, is this a function or not? Does the input, because a function, the definition, if you remember, the input has exactly one output. In this case, if I draw a vertical line anywhere on my graph, or what I graphed, it looks like it's only intersecting at one point. Therefore, this is a function, because my inputs, looks like no matter what they are only going to have one output. Moving on, let's take a look at number 11, which is right here. This is number 11. If I have a graph, so oftentimes they'll just give you a graph, and your job is to determine, is this a function or not? I have no data, I just have the graph given to me. If I draw a vertical line, it intersects my graph in two spots. Therefore, this is not a function because my vertical line is intersecting the graph in two different spots. It's intersecting it at point 1, 2, and it's intersecting at point 1, negative 3. My number 1, my input, has an answer of 2, and I also have an answer of negative 3. Therefore, my input has two outputs, not a function. Looking at number 12, here are my input values, here are my output values. I have an input of 2, an output of 3. I also have another input of 2 and an output of 6. Because I have an input of 2 and an output of 3 and an input of 2 and an output of 6, I have two different outputs. If I'm just giving data, I don't even have to graph it. I can say this is not a function. Again, go back to the definition of a function. Because it has, go back to the definition of function, you realize that the input can only have one output. In this case, my input has two outputs. Therefore, it is not a function. Like I said, you probably have to rewatch this a couple times. We're still a little jittery on it. We'll do notes the next time we have class to clear everything up. Have a wonderful day.